All right, this is going to be part 2 of these review questions and going through some of the different answers here. So starting off with number 23, I want to find the square root of n to the fourth. The way that we talked about doing this whenever I have radicals or square roots is I talked about how having to break it up by its factors and looking for prime numbers. So for instance, if I wanted to break up the number 36, I could break that up into 6 and 6. Neither of those are prime, so I would try to break those down more. I could break up the number 6 into 2 and 3. Both of those are prime, so what we talked about is that we circle those. And then same thing with this number 6 as well. Break it up into 2 and 3 and circle them. One other thing that we can do here as well is with n to the fourth, I can write that longhand. So that's the same thing as n times n times n times n. And then what am I looking for here? Well, we talked about with square roots, or when there's a number 2 right there, I'm looking for matching groups of 2. So what I have here is I have a matching pair of 2's, so I will take out a singular 2 for that. I have a matching pair of 3's, so I will take out a singular 3 for that. And since I have a 2 and a 3 outside of my radical now, I'm going to go ahead and make sure that I always multiply those things. And then what else do I have with matching pairs? Well, I also have variables as well. So I could have a matching pair of n's. So I'll take out a singular n for that pair, and another matching pair of n's, so another singular n for that pair. And then typically I would write the square root symbol, and then I would write stuff below it. But actually everything got paired up here, and so there's nothing left under the radical, and I can actually leave the radical symbol off now. So what do I get when I do this final multiplication? I have 2 times 3, which is 6. And I have n times n, which is n squared. So final answer would be 6n squared. All right, next one here, the cube root of 216x to the fourth. So I have the same kind of idea of trying to break up the number first. 216 is a very large number. I might not know a lot of the factors that go into it, but it is even, so I know that the number 2 definitely goes into that. And if I type this into my calculator, 2 times 108 is what would give me 216. And I found that by just doing 216 divided by 2. So what do I have here? Well, 2 is a prime, so I can circle it. 108 is not. Again, that's a large number. I might not know many of the factors, but I know it's even, so I know 2 has to go into it. And if I check that on my calculator, it goes in 54 times. And I could actually keep doing this process until I find a number that's not even. So 54, also even, so I know 2 has to go into it. That goes in 27 times. And finally, I've got an odd number, so 2 is not going to go into it, but I could check and see if 3 does, and it does, and it would be 3 times 9, and then 9 can be broken up into 3 and 3. So this is what we do when we are breaking all this up into all of its prime numbers. All right, and then for x to the fourth, same kind of idea that we did on number 23. We're going to write x times x times x times x. And what am I looking for here? Well, I'm looking for matching groups, but this time, since it's a cube root, I'm looking for groups of 3. So I have a matching group of 2's, and there are 3 of them, so I'll take out a singular 2 for that group. I also have a matching group with the 3's. Again, there's 3 of them, so I'll take out a singular 3 for that group. And then finally, for the x's here, I do have a matching group of x's. And then like I mentioned, once you have all these taken out of the radical, you draw your radical symbol, and I'm going to make sure the 3 is on that, so a cube root. And then the only thing that did not get paired up or matched up with anything was that lone x that is sitting at the end there. So that actually needs to stay under the radical because it didn't get grouped up with anything. So then what's my final answer? 2 times 3 is 6. So I would have 6x and then the cube root of x. Okay, so those can be a little complicated, especially trying to figure out what goes on the outside, what goes on the inside. So just make sure you're looking for matching groups of things. All right, 25 and 26. Both of these could be entered in your calculator, but the way I can think about it is this. I want to find log base 4 of 16. So I know that equals something. We'll just call that x. And what we talked about is these can be rewritten as an exponential equation. This is the same thing as saying 4 to the power of something equals 16. And you need to figure out what that power is. Well, that power would be 2. 4 to the second power equals 2. So in other words, x, or in other words, this, if I type it into a calculator, equals 2. Same idea with the next one as well. log base 6 of 1 over 36 is what I'm trying to find, so maybe we can just call that x. And then if I rewrote this as an exponential function, this would be saying 6 to the power of something equals 1 over 36. And I need to find what the power is. Well, I know 6 to the second power is 36. If I have 1 over 36, we talked about this, it would just be a negative version of that number. So 6 to the negative second power would equal 1 over 36. And again, if I typed that into my calculator, I would end up with the same result. All right, 27, I want to condense each of these expressions into one logarithm, and I can do that. So the first thing we talked about when we are trying to condense is we can take any number that's on the outside or in front of the logarithm, and I can move it up to an exponent of the value that I have. So this would be the same thing as log of x to the fifth plus log of y to the fifth. So that's the first step in condensing these. And then one last thing that we said is I can condense them into one logarithm that has that same base. So in this case, this is just log, which has a base of 10 technically. And then what we said is I can combine these, and we said if that we are adding the two logarithms, then we multiply the two values. So this would be the same thing as log x to the fifth, y to the fifth. And I'm just putting them right next to each other because they would be multiplied. So then same idea with number 28. Take the numbers in front, move them up to the exponent. So this is log x to the sixth minus log y to the 12th. And then here we have a similar idea. We're trying to combine this into one term, but the difference is that we are subtracting, and what we said to do with those is we divide the values. So this would be the same thing as log of x to the sixth divided by y to the 12th here. And that would be my final answer. All right, moving right along. Number 29, I have the square root of 2n plus 104 equals 10, and I want to solve this equation for n. So anytime I have a square root, what I can do to get rid of it is I can square both sides of the equation. So when I square the left side, the squared and the square root will cancel each other out, and I will just be left with what is underneath, which is 2n plus 104. On the right side, I have 10 squared, which is 100. And now I'm just going to solve this equation for n. I'm going to subtract 104, and I'll end up with 2n equals negative 4. And then last step, I'm going to divide by 2, and I'm going to get an answer of n equals negative 2. So remember that rule. If you see a square root and you need to get rid of it, square both sides. So same thing with 30. I'm going to square both sides. On the left side, I would have 5 squared, which is 25. On the right side, these things would cancel each other out, and I'd be left with 7n minus 3. And then solve for the variable. So add 3 to both sides, and you get 28 equals 7n. And then divide by 7. I'm going to go ahead and flip this around. N equals 28 divided by 7, which is 4. All right, next one's here, dealing with exponential growth and decay. So Bobby invests $700 in an account, accruing interest at 2.5% annually, and those formulas are actually listed below for me. How much will be in his account after 5 years? So what we said with these equations is we said that we're going to start off with capital A of t, which is the total amount after a certain amount of time. I'm actually going to use this one with the plus sign because it is increasing in value. And so I'm going to start off with A of t equals, and then I get to lowercase a. Lowercase a is representing our starting amount. So the starting amount in the bank account was $700. And then I'll say parentheses, I'll say 1, I'll say plus, and then I get to r in the equation. R is referring to the interest rate, which is 2.5%. And as a reminder, we've talked about this. This needs to be expressed as a decimal. This is expressed as a percentage right now. So what we said to do, the process of what we said to do was to take the decimal place and move it 2 to the left. So this is actually 0.025 as a decimal. And then all to the power of t, which is the amount of time that has elapsed. They are asking for what is going to be in the bank account after 5 years. So that is my exponent that I'm going to put in there for t. That's going to be 5. So if I wanted to, I could go ahead and simplify this here. A of t equals 700, 1 plus 0.025 is 1.025. And then once I get to this spot, I really could just type this into the calculator. So I'll just show that here real quick. Let's see if I can get my calculator pulled up. You can see the statistics that we were doing in the last lesson. So I have 700 and then times 1.025 to the power of 5. So I'll try to see if I can get most of this to fit on the screen here. Let's see, 700, some of the numbers are going to be off your screen. And then parentheses, 1.025 to the power of 5. So to the power of, make sure you hit that caret, and then 5, and you should get your answer. 791 point, let's call it 99, since we're talking about dollars and cents, we would round off to the second decimal place. So how much is going to be in the account after 5 years? That's going to be $791.99. And that would be our final answer. All right, another exponential growth or decay question. The rhino population is currently 853 rhinos. The population is decreasing at a rate of 17% per year due to illness. Estimate how many rhinos will be there after 4 years. So I'm going to use these same kinds of equations, but this time I'm going to use the second equation because we are decreasing in value. The rhino population is decreasing. So I'll set up that same kind of thing. A of t equals lowercase a, which is our starting amount, which is 853 rhinos, and then 1 minus our rate here. Our rate is 17%. As a decimal, that is 0.17. And then all to the power of t, the amount of time that's elapsed. In this case, they're asking for what the rhino population would be after 4 years. So I'll go ahead and simplify this here. If I want to do one thing real quick before I type all of it in my calculator, I could do 1 minus 0.17, which is 0.83, and all to the 4th power. You don't have to do that, but could just be a way to write things in your calculator a little bit simpler. And then let's type in those same values. So 853 times, in parentheses, 0.83, close the parentheses, to the power of 4. And I get my final answer, which is 404.82 rhinos. So let's go ahead and just round this down. Since we're dealing with whole numbers, we're dealing with rhinos, so let's say maybe about 404 rhinos. And I know that's 404.8, so technically with 0.8 you would round up, but since we're talking about whole rhinos, once we dip below 405, I would want to go to the next whole number, which is 404. Okay? All right, still working through some here. So 33, I want to factor each completely. We had a process that we use for this. This is what we call factor by grouping, where I have something with n cubed and I have 4 different terms. So what we said to do is we said to group the first 2 terms together, group the second 2 terms together, and then take out the greatest common factor that is in each group. And so if I had this type of problem, if I just look at the first group, between 16n cubed and 56n squared, the greatest common factor is actually 8. 2 goes into both of them, 4 goes into both of them, but 8 actually is the largest number that goes into both. And then what else do they both have? They both have a few n's, and at the very least, they both have 2 n's. So the greatest common factor is actually 8n squared. And then I would start parentheses, and I would write what's left over if I divided 8n squared out of both these. Well, if I did that, the first term would now say 2, and I would just be left with a single n. And then on the second term, the n squareds would be taken out, and then I would just have 56 divided by 8, which is 7. Then I move to the second group here, same kind of idea. What's the greatest common factor? In this case, the greatest common factor is actually just 1. There's not any other number that goes into both those. So it would just be 1, and then what's left if I divide them by 1? Well, that should be pretty easy. It would just stay the same, which is 2n plus 7. And you will know that you've done this method correctly if these things in the parentheses end up being the same values. Okay, they should be identical. And then what do we do with this? Well, we actually get 2 answers from this kind of problem, 2 different factors. The first factor is always going to be that matching term that is in, or the matching expression that is in those parentheses, so 2n plus 7. The second factor is going to be the other values that are outside of them, so 8n squared and plus 1. And this is the quickest way to get those two factors here. All right, same kind of idea with number 34 then, if 33 was confusing you. Group the first two terms, group the second two terms. Greatest common factor of the first two is 5 and then x squared. And then what would be left over? That would be 2x, and that would be 7. Second group, same kind of idea. What's the greatest common factor? Well, that would be 4. And actually, both of them have negative numbers on them. So I'm actually going to take out a negative 4. And when I do that, what would be left over is I would be left over with a positive 2x and a positive 7. So it was actually nice that I took out that negative 4 because now those things in parentheses are matching. So my final answers, I'm going to have two factors. One of them is going to be that matching expression in the parentheses. The other is going to be the two things that are outside, 5x squared and negative 4. And this would be my final answer. All right, 35 and 36, working with radicals here. So how do I simplify these here? Well, I can only add things together if the bases, so in other words, the numbers under the square roots, are the same. So I notice all three of those right now are not the same, but 27 can actually be simplified. I can actually break that up, like we've done with radicals on this review, into 9 and 3, and then 3 and 3. And what we said with these is when I have a radical, I look for matching pairs. And so I can actually take out a single 3 that would go on the outside of the radical now. So I'll go ahead and actually write that here. I would have a 3 on the outside. And then what was already out there to begin with? Well, there was already a 2 out there to begin with. So I have that 2, and then I'm going to multiply those two things together. Then I'll have my square root symbol, and then I find the one thing that was not paired up, which was that lone 3 that was not paired up with anything. And then what else do I have in this problem? Well, I still have this first term here, negative 3 square root 3. I also have the second term plus 2 root 5, and then plus all this stuff. So I can go ahead and do that multiplication that I set up right here, 2 times 3, so that is 6, and then root 3. And then actually now I do have two things that have the same base, so those can be combined. And so when I combine them, I treat that very similar to variables, where I combine the numbers out front. So negative 3 and positive 6 combine to give me positive 3, and then I leave the radical the same. So I have 3 root 3, and then I have plus, and then this radical still, 2 root 5. All right, next one's here, same kind of idea. I want to break up any of the terms that I can. So I can break up this 20 actually into 4 and 5, and then 2 and 2. I look for a matching pair, which is a 2 here, so I can take out a single 2 for that matching pair. And then notice I already had a negative 2 out front to begin with, so negative 2 times 2. Then I draw my radical symbol. What was the one thing that did not get paired up? That was the number 5. All right, next one can be brought down. I could break up 6, but I wouldn't get any matching pairs, and so I would just leave that the same. And then the 24, that can be broken up into, let's say, 2 and 12, 2 and 6, and 2 and 3. Look for the matching pairs. That would be a 2. So I would take out a singular 2 for that, and then notice there was already a 2 on the outside. So I have those two things. And then what's left? Well, these two things did not get paired up, and so I would have a 2 and a 3 on the inside, and I would multiply those together. So what do I have after all this? Well, I have multiplication at the beginning. Negative 2 times 2 is negative 4, plus the second term, and then the last term plus 2 times 2, which is 4, and on the inside 2 times 3, which is 6. And now after all this work, I have two things that actually can be combined, and that would be 2 root 6 plus 4 root 6, which would give me 6 root 6. This would be my final answer. All right, a few more and then we'll be good for today here. 37, I have these things being multiplied. The nice part about multiplication is that you do not have to have the bases be the same, so you just multiply everything that's under the radicals. So 5 times 20 would give me 100. K to the third times k to the third would give me k to the 6th, because you actually just end up adding all those things together. And then we have a negative 5 on the front. And what do I do from here? Similar to what I've done with square roots in the past. I try to break it up. So 10 and 10. And actually, this is a matching pair. So I'm actually going to stop there. And then k to the 6th would just be multiple k's all written out, 6 in total. And I would look for matching pairs. So matching pair, matching pair, matching pair. So I'm going to take out 3 different values of k for all of those matching pairs. I'm also going to take out a 10 as well and multiply it by the -5 that's out there. And so the final answer is -5 times 10, which is -50, and then k to the 3rd. And this would be my final answer. And typically I would draw my square root symbol and then I would write something below it, but actually everything got paired up here, so that is my final answer. Same idea with 38. Multiply these together. I'd have my square root symbol. 6 times 12 is 72. X to the 3rd times x is x to the 4th. And then same idea, kind of break this up here. So I'm going to break it up into 2 and 36. 36 I'm going to break up into 6 and 6. And usually I would break that down more, but actually that's a matching pair, which is what I'm looking for. So I'm going to go ahead and just circle that matching pair. And then with the x's, same idea, write them out longhand. So matching pairs, what do I have here? Well, I have a 6, so I can take out a singular 6 for that matching pair. I have 2 different groups of x, so I'm going to take out 2 different x's, which would be written as x squared. And then I would draw my radical symbol, and what's the only thing that did not get paired up? That was the number 2. So my final answer here would be 6x squared and then root 2. Okay, and I apologize if I'm going a little too fast. If you have any questions, feel free to ask when you are in class. All right, 39, we're going to subtract these 2 things. We actually just did this on the Unit 9 quiz and the Unit 9 test. For subtracting and adding, the denominators have to be the same. So what do I have to do? I have to multiply the first fraction by n minus 1. Same thing on the top. Multiply the second fraction by n plus 2. So what do I get when I do that? Well, I have 3n times n and times -1. That would be 3n squared minus 3n over that common denominator that I'm creating, n minus 1 and n plus 2. And then minus 5 times these 2 things. So that would be 5n and plus 10, and then over again that denominator, that common denominator that we are creating. So now what can I do from here? I have one last step. I'm just going to take the things on the right and subtract them from the things on the left. So when I do that, I have 3n squared, which will not change. I have -3n minus 5n, so that would be -8n. And then I have nothing minus 10. Nothing minus 10 is -10. And then all over that common denominator that I created, which is n minus 1 and n plus 2. Same idea at number 40, make the denominators the same. So I would multiply the first fraction by 5a plus 3. Multiply the second fraction by 4a. What do I get when I do all this multiplication? Well, I would have 25a plus 15 in the first fraction, and then underneath that common denominator that I was creating. And I'm sorry, that's 5a minus 3, so I need to fix that. 5a minus 3 on the top and on the bottom, which will just change the positive 15 to a negative 15. And then plus, second fraction here, same idea, I'm distributing. So 4a times a is 4a squared. 4a times 2 is 8a. And then over that common denominator, which again, I needed to make sure to change so it said minus 3. And then last step, I just have a bunch of like terms to combine on the top, and I'm going to write them in order from highest exponent to lowest exponent. So this would be 4a squared. Combine these 2 things to get plus 33a and then minus 15. All over that common denominator that I created, 4a times 5a minus 3. All right, number 41, I want to try to simplify this. Hopefully we've just gotten in the habit by now throughout this whole class that if you see anything like that, that is a quadratic, get in the habit of trying to factor it. So factoring it would be finding the 2 numbers that if I add them, I get positive 6, and if I multiply them, I get negative 27, and those 2 numbers would actually be 9 and 3. So the 2 factors that would come from that would be p plus 9 and p minus 3. So actually this is what my fraction looks like. And then we had a rule that we said if you have the same value on the top and on the bottom, they can cancel each other out. So what am I left with? Well, on the bottom, I have p minus 3, and then I do need something here on the top. technically that p plus 9 canceled out, so what would be left is just the number 1. So my final answer would actually be not p minus 3, but 1 over p minus 3. All right, 42 is a multiplication problem, so it's actually a similar kind of idea. I want to factor everything I can and then cancel anything that is the same on the top and on the bottom. So when I factor this, two numbers that add to -3 and multiply to -10 would be -5 and +2. So b minus 5, b plus 2. And then actually, I was going to go and factor these two things, but I noticed right now that they're actually identical. So I know everything's going to cancel from them. So I'm actually going to save myself a little time and just cancel them out right now. And then as for 7b plus 14, this can actually be rewritten as well. To rewrite this or to factor this, we just take out the greatest common factor, which would be 7, and then I would be left with b plus 2. So what else cancels? Well, the b plus 2's cancel here. And so final answer on the top, I have b minus 5. On the bottom, I have 7. All right, almost done. A few more here. So number 43, a pharmaceutical company is testing a new medication that is supposed to shorten the number of days a patient experiences symptoms of influenza. It was tested on 45 patients, and the average number of days until symptoms was cleared was 5.3, and a standard deviation of 1.1. So what it says with this is all it says is to identify the population in the sample from this situation here. So we talked about this in class. We said that the population is the big group that I'm trying to learn information about, and then the sample is just the smaller subset of the population that I actually gained the information from. So they're testing a new medication to test that is supposed to shorten the number of days a patient experiences symptoms of influenza. So the whole population that I'm trying to figure out information about is people with influenza, which really could be anybody who is capable or possible of catching that disease. So that's the entire population. And then what's my sample that I got from that? Well, I got a subset of that population that was 45 patients. So that would be my sample. All right, we talked about how you can cross out number 45 and 46. So last one, number 44. Find the mean and standard deviation of this data set. So what we said we're going to do is we're going to type all of these in a list here. So I'm going to go ahead and do that on my calculator. I'm going to go ahead and clear out what I have. I'm going to hit, let's see. Oh, I'm going to clear. There we go. I'm going to hit Stat and go to Edit and hit Enter. And then I'm going to go ahead and list all those values out. If there's anything in the list, I'm going to go ahead and clear that out. So I hit Clear and Enter. And then I'm going to try to type in all of these values here. So 50, 72, I'm going to hit Enter after all these. 83 I saw was the next one. 92, 92, 84. So I'm going to enter in 92 multiple times. 92, 92, 84. And then what's the last ones here? 100, 82, and 95. 100, 82, and 95. Okay, I have these 9 values it looks like. Now I want to find the mean and standard deviation. So the way that we find that, and watch this on the video, is Stat, go over to Calc, and choose the first option that says one variable statistics. You want list 1, frequency list can stay the same, and that is my final answer. This is my mean, which is X bar here. This is my standard deviation. So I'll go ahead and write these values in. The mean here is 83, or what we call X bar, is 83.33. Standard deviation is that number that is S of X. So that is 15.025, let's call it. Let's round that off to the third decimal place, 15.025. Okay, so if I went through any of those too quickly, feel free to ask me in class if you have any questions, but hopefully this video helped you to at least see some of these problems written out and explained.